Okay, cool. So let's go over the range. The range, so I'll say let f from A to B be a function. Let f from A to B be a function, then the range of f, right? I like to capitalize it. The range of f, this is the set of all things that get hit. It's a set of all things in the codomain that get hit by the function. So this is going to be all y in the codomain, which is b in this case, right? We define our inputs are in A, our outputs are in B. It's all y in B, such that there exists an x in the domain such that f of x equals y. This totally captures the idea of being hit by an element in the range, right? Or being hit by an element in the domain. So, yeah. So you are in an element is in the range of f, if and only if, right? There's some x you can plug into f that will get you that number. And so this means the range excludes things in the domain that don't get hit. If you're not in the range, that means that no matter what you plug into A, f of x is, or no matter what you plug into the function, f of that's not going to equal that element. So to do an example, right? Let's say, example, if we have let f be as above from the real numbers to the real numbers, such that f of x equals x squared, then the range of f is going to equal all y in the real numbers, the codomain, such that there exists an x in the real numbers, such that f of x equals y. Which doesn't really tell us much here, but it's going to turn out that that's going to equal the set of all y in R such that y is greater than or equal to 0. Because this function f(x) squared, it's going to be, it's going to hit everything 0 and above. And we could actually prove that. We're running out of time, so maybe we'll do that next time. The point is you prove that by proving that these two sets are equal. And how you prove sets are equal, you prove they contain each other. So you'd start with an element of y that gets hit and prove it's got to be greater than or equal to 0. And then you have an element greater than or equal to 0 and prove it's going to get hit. That's what the range is. It's all the things that get hit. And so I'll do another example real quick. And that is, this will be an interesting one. Let f, or let's say what's a funky letter? Let's just call it g. Let g be a function. It's not going to be this one, it'll be a different one. Let g be a function from the natural numbers, actually let's say the integers, from the integers to the rational numbers by g of n is going to equal n over 2. So g of n is going to equal n over 2. So the question is, so the domain Z and the codomain is Q, right? That's the easy guess from the definition. The domain Z codomain is Q. Now the question is, what's the range? So the range of G, by technical definition, is going to be all the y in Q such that there exists an n in the domain Z such that g of n equals y. But notice this is not going to be every rational number. For example, 1/3 will never be hit. For all n and z, g of n will not equal 1/3. So 1/3 is not in the range. The reason you can see this is true is because if it did work, well then you'd have g of n equal 1/3. Well, g of n just always gets you n over 2. You have n over 2 equals 1/3, meaning if you cross multiply, you get 3n equals 2, which implies that 3 divides 2, and this is a contradiction. This can't happen. The point being, not every element does get hit. So the range is not just all the rational numbers. It's simply all the rational numbers of the form n over 2. Obviously, right? Because this just takes every integer and divides it by 2. And so everything in that range is, so the range is going to be every rational number that can be written as n over 2. Not rocket science, right? Maybe we'll do more with this next time.